Okay, so today we're going to talk about combinations. In 11.2, we talked about permutation. The big difference is in 11.3, the order makes no difference. So we're still going to take a group of items from some total number. No item is used more than once, and then the order makes no difference, or the book may say order does not matter. Or maybe order isn't important. Something along those lines. So examples of where this will come into play is as follows. The one we mentioned the other day, or in the last video, was toppings on a pizza. So you wouldn't say put the pepperoni first, then the onions, then the mushrooms. Generally, they just put whatever's first on the line. Okay. Selecting members of a committee, that's something you're going to see in the homework. And this is different than choosing a president, vice president, secretary, because in that case, each person was assigned a position. In this case, you're going to say, here's 20 people, I want 5 of them on the committee. How can I do that? How many ways can I do that? And then the other one being dealt or maybe we'll say drawing cards from a deck. In this case, the order doesn't matter. If I were to have some cards, so if I were to choose some cards, I'm just randomly choosing some cards. In poker, you have 5 cards. And so I'm just randomly grabbing 5 cards. This is not how you would choose 5 cards. But anyway, I just randomly grabbed 5 cards. Almost have a straight, not quite. But in this case, I have a pair. So I put the tens next to each other. If I move stuff around, I still only have a pair because I only have 2 tens. But the fact that I can rearrange these and the order doesn't matter still would be considered the same hand. That is what is meant by order doesn't matter. Okay, so I'm going to put this one on here too because there's a kind of a weird question you're going to see, but the lottery. In that case, you choose some numbers, and it doesn't matter what the order of those numbers are chosen. If your numbers match the numbers that is chosen for the lottery, then you win. So that's some examples. All right, so we also have a formula for this. So the combination formula. It's very similar to the other one. In fact, I could derive the combination formula from the permutation formula. But if you're interested, I'll let you just read the book. So, the number of possible combinations if R items are taken from N items, so in the total item is NCR. So like with the permutation, P was capital and the two other letters were smaller. So these are really subscripts. The C is a capital letter. But that is defined as n factorial over n minus r all factorial times r factorial. Okay, okay, so here's an example. I got two examples that I want to do, and then we'll stop the video, and then we'll do. So example one. So you don't have to know how to play this game. All you need is in the question. But in Texas Hold'em, a player is dealt. So Texas Hold'em is a type of poker. But in this situation, all we need to know is that a player is dealt 2 cards from a deck of 52. It should be noted that this is a standard deck. We'll talk more about this for probability. So anytime I say a deck of 52, I'm talking about a standard deck of cards. The question is, in how many ways can a player be dealt 2 cards? Okay, so I grab my deck of cards again. Okay, so basically if you draw 2 cards or are dealt 2 cards, I'm just going to grab 2 randomly. So in how many ways could I do that? Well, I don't really need to see what the cards are. I can still work the problem out. We will look in a second. But since the order doesn't matter, meaning I chose this one first, then I chose this one, but it doesn't matter because if I chose that one first and that one, that still is the same starting hand. So since order does not matter, I'm going to make a note here. Order does not matter. Always ask yourself, does order matter? Yes or no? And that tells you permutation or combination. So I can use my combination formula. So that's my total. That's what I'm choosing. So 52 choose 2. Well, I can use the formula, and I'll do it with the formula right there. All right, I'll use this formula, but I can type it in the calculator. So I feel like I should show you this first. So show you how we work this by hand, and then we'll do it the short way. So R is 2. Okay, I'm running out of space, but this is fine. 52 factorial. 52 minus 2 is 50 factorial times 2 factorial. I want to show you by hand how to handle this. I could type that in the calculator. I could do this by hand. So up top, 52 factorial is 52 times 51 times 50 times 49, all the way down to 3 times 2 times 1. And this is 50 factorial, which is 50 times 49 times blah, 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 all the way down to 3, 2, 1. I also have a 2 factorial, which is just 2. So in this case, all of this cancels. I still got that 2 there. So I guess I still got to use the calculator here. So I got 51 times 50 divided by 2. And I get 1326. Okay. Now, like I said, I could have just done this by hand. So in this little space here, I said by hand, on the calculator. So in this space here, I'm going to do 52, choose 2. All right, so let me show you where that is. 52. We go back to PRB, NCR. Then we choose the number 2. And we get 1326. So this is going to be the quicker way to do these. Many of you will. So let's see what we were dealt. Queen 7. This is not a very good starting hand. Okay, so the next basic example I want to do is involving the lottery. So example 2. There's going to be an example in the homework similar to this. Because it's the same basically with different numbers, I probably won't make an initial video about that, but maybe I can if there's some questions. All right, so in the Louisiana Lotto, player picks 6 numbers. From a group of 40 numbers. Basically, and how many ways can someone choose these 6 numbers? Okay. Well, the group that we can choose from is 40. We only need to choose 6 numbers. So this is nothing more than combination. In fact, most of the questions in the homework for this section are going to be combination problems. So I'm going to type this in. 40, PRB, NCR, 6. Get a big number, 3, 8. 3, 8, 3, 8, 3, 8, 0. So it looks like 3,838,300. Okay. So that's the basic information you need for the homework. I will go through some homework problems. Some that I think are going to trip you up maybe. But no, that's about all there is to 11.3.